Hello everybody. So today I will talk about calculus. The topic today is about Cauchy residual theorem. So now I will show you how to answer. First, we need to graph about this one. We know that z equals to a plus b I. Now we have negative number 5. So we have a minus 5 plus bi. We know that this one for the real. This one, that's about imaginary. So because that is inside the absolute value, so we will have the formula in here. So we have a minus 5 to the power of 2, and the next one b to the power of 2, and we know that this one equals to number 3. And now if we put the power 2 for the both sides, and we have a minus 5 to the power of 2 plus b to the power of 2 equals to 3 to the power of 2. So if we look carefully about this equation, this is about the circle, and the center, that's about 5, 0. Number 5, that's it from here. This one we don't have the number, that's about negative number 0. So that's why we have number 0 in here. And the radius, that is about number 3 from here. And now we need to graph about this one. So this is for real. This one for imaginary. Now we have number 5. So number 5 should be in here. Number 0, that is in here. The circle, we have the radius is about number 3. So 5 plus 3, we have number 8. 5 minus number 3, we have number 2. And now let's go to this function. So we need to consider about the pose of f of z in here. So we need to concentrate about this one. So that is about the denominator. So we have z minus number 3. We put equals to number 0. So we have z equals to number 3. The next one, z minus number 6 equal to number 0. So we put this one go to here, and we have positive number 6, and z minus number 9 equals to number 0. So we have z equals to number 9. Now when we go back to the graph, we have z equal to number 3. So number 3 should be in here. Number 6 should be in here. Number 9, that should be in here. So we see that number 9 is outside this circle in here. So we can say z equals to number 9 does not contribute to this integral because z equals to number 9 is outside about the contour in here. So we just have the poles of f of z that is about number 3 and number 6. So this is about the first one. Now we go to the second step. So as z equals to number 3, so we will have 3 of z equals to z minus number 3 multiplied by f of z equals to, so we have this one. So we multiply by z minus number 3. So we will have like this. And now we can find about residue of f at location number 3. So we will put number 3 go in here, number 3 go in here, and number 3 go in here, and we can calculate this one, and we have 1 over 3. After we put number 3 to change for z, now let's go to the second one as z equals to number 6. So we simplify and we have like this. And now we can find about residual. Now we put number 6 go in here, number 6 go in here, and number 6 go in here. So we have negative number 1. After we find anything in here, and we have the final answer in here. That is about 2b8. We multiply about this residual plus this one. So we have 2b8. This one we have 1 over 3. This one we have negative number 1. And now we have the final answer. That is about negative number 4 over 3 b I. And that is the final answer. So the formula of this one, they should be like this. That should be about the summation of everything residual in here. This is the end. Thank you for watching.